Hello, my name is Jonathan Bisnet, and in this video I'm going to show you a piece of a project that I'm working on. This is really focused around using the Intel Edison, a new microcontroller, well actually not even that, a system on a chip, an SoC, that was put out by Intel. In fact, the device is back here. It's actually attached. You can see here it's actually attached to a slightly larger board that its only purpose really is to allow power to get to the unit as well as to give me a way to interface with the pins from the microcontroller, but it's relatively thin and small. It's a little bit larger, maybe 1.5 times the size of a that's not even good. Let's say it's maybe an SD card, maybe 1.5 times the size of a standard SD card. I then tie all of those pins off the back, the ones that actually deliver signals to the breadboard. So I've basically just used a series of wires to connect them, along with pulling off some specific power and ground capabilities here. The Intel Edison runs on basically a 1.8 volt, uses 1.8 volts I should say, and its pins are not 5 volt tolerant, so there you do have to take some care when interfacing them to other devices. But anyway, I'm kind of getting ahead of myself here. This is really the result of some ongoing work on a blog that I'm putting together. The blog is Intel Edison Explained.blogspot.com, and I will include that in the comments for this video. And this project is fully laid out in there. In fact, there's several additional blogs prior to this that get into a lot of what I'm doing down here, which has to do with level shifting that 1.8 volt signal to a 5 volt signal to drive the LCD. I also, since the Intel board is giving me 1.8 and 3.3 volt sources off of it, I also have included over here a nickel metal hydride battery that I'm tying in over here through a low dropout regulator in order to power the LCD. So if I kind of take that in there a little bit, you'll see I got the regulator here, a couple of caps, not much to it. There's a switch which allows me to, in essence, control the power to the display. So if I turn it off, the display goes away. Turn it on, the display's back. So this 5 volt setup is electrically isolated from the Edison, but the transistors used in here, they're actually MOSFETs, and they will level shift that 1.8 volt signal coming from the Edison to a 5 volt signal, which is what the LCD wants. Anyway, this is all laid out fairly clearly on my blog, but I've also, at this point, put together the program to drive the display. That's also on the blog, but I'm going to go ahead and run this program here just so you can see the display do something. Kind of turn that away a little bit. There we go. Run. Oh, sorry, I'm going to do that again. I had to actually log into the Edison. It runs a Yocto Linux version. There we go. Hello world, I'm Edison. It runs a Yocto Linux version, so when I communicate to it, I actually have to log in for the program to be sent down and executed by the controller. This last one where you just see the A, it's basically a piece in the code where I have read back a letter off of the LCD and re-show it just to confirm that I can read the data on the LCD, not just write it out. But anyway, that's the basic project here. I found the Edison to be a very, very interesting microcontroller. Well, again, bad term, system on a chip. It seems to be well designed for the purposes of doing system on a chip type functions. So embedded code, you could easily put this in any number of devices, especially relative, due to its relative size. It's programmed in this particular case in a standard C, but you could also have C++ or Python or a number of other things. Anyway, that's really all for this video. You can expect that I'll throw a few more together as I interface other devices. But I would encourage you to go take a look at my blog, especially if you're at all interested in the Edison and what it can do. Thanks for watching.